Okay, 7.2, doing number 25. I'm jumping into a harder problem. We're using the substitution method, and what we have is a line for an equation. An equation for a line. So here's one line, and here's another line. Two lines, and we're going to basically put them together. And I like to explain it that way because the intersection of two lines is what the chapter is really about. And putting them together, you know, if we put the equations together somehow, we're going to get that intersection because that's where the lines actually are together. So that's the logic, and the way we do substitution method is we have to isolate something. Like, let's get x isolated. I want to move the furniture so this cancels out, and I have x equals 0 plus y is just y, so x equals y, which is an interesting situation because now I could plug in, since x equals y, I can just actually plug in y right here. Since x, wherever we see x, I can put y, is what this is saying. So 12y, normally we have more information to have to plug in, but because the way this worked out, we just plug in y. Usually it's like y plus 2, and then y plus 2 would go inside the parentheses. And that is one safeguard that I have to suggest for all my students. The moment they substitute, I want to see some parentheses. It's a good habit because in this case it's not such a big deal because it's just one element going in there. But if it was a y minus 2, we would need a y minus 2 inside those parentheses, and the parentheses would help protect us to keep us from forgetting to distribute that 12. I'll have to do another problem to show you an example of that, but anyways, continuing on with this, 12y minus 5y equals negative 21. That minus that is going to be what? 7y equals negative 21. Divide by 7, divide by 7. Y now equals a negative 3. So that's half of our information, because as we know, we're trying to find the point of intersection, which is an ordered pair, x comma y. We now know our y part is this, and it just so happens since our y is equal to the negative 3, we can put it right there, and that tells us x is equal to negative 3. So there's our ordered pair. And since I've raved and raved about students checking their work, let's go ahead and draw a line and check this thing. We'll write our original equation, and we'll put x and y, negative 3 minus a negative 3. There it is. There's an example of how you've got to put parentheses around what you're substituting, because if you didn't do that, you would lose this negative, and what we need is for the negative times a negative to become a positive here. And that's the truth. 0 equals 0. Yes, it is on the line. I won't write all that out, but, well, I'll go ahead. So what I tell my students to do is on the line. Solution. Now I realize that checking it like this does seem optional, but like I said, I think it's foolish, especially on a test, not to check it and make sure that you're doing this right. And obviously, if students aren't practicing that on their homework at least a few times, then when they get to the test, they might not remember to, or might not remember how to do that step. So, what's this? Negative 36 minus, or plus, because negative times a negative is 15, and 21, 36 minus 15, negative 21 equals negative 21. Yes, 3 comma negative 3 is on this line, which is what solution means. And if it's on this line and it's on that line, it is the point of intersection. So if I had more room, I would put that little bracket down there and say it's a point of intersection because it's on both lines. So that's how we do the substitution method.